Hi everybody, it's Miss Austin. I'm going to be doing the Unit 2, we're in a new unit, Lesson 1, practice problems. We're doing 1 through 6, skip 5. It says when rectangle ABCD is reflected across line EF, the image is DCBA. So let's just look at that. ABCD is reflected across line EF. The image is DCBA. How do you know that the segment AB is congruent to DC? A rectangle has two pairs of parallel sides. That wouldn't help me with any congruent statement. Might help me with some angles, but any two sides of a rectangle are congruent. That is true, but not any two sides, only opposite sides. Congruent parts of congruent figures are corresponding. No. Corresponding parts of congruent figures are congruent because the reflection across EF produces a congruent shape. We know that corresponding parts that line up with each other. So AB is the same as DC when it's reflected. And because those two rectangles are congruent, right? So corresponding parts of congruent figures, those two rectangles are congruent, and those two sides are corresponding, then those have to be congruent. All right, number 2, triangle FGH is the image of isosceles triangle FEH after reflection across the line HF. So FGH is the image of this reflected across this line. You want to imagine it. There it is. Okay? Select all the statements that are a result of corresponding parts of congruent triangles being congruent. So any parts that match up have to be congruent. A, EFGH is a rectangle. EFGH is a rectangle. Well, I can clearly see those aren't 90 degrees, and a rectangle has 4 90-degree angles. EFGH has 4 congruent sides. If these two sides were congruent, and I did a reflection, then these two sides are also congruent. So yes, it has 4 congruent sides. Diagonal FH bisects angle EFG, that's this angle, and angle EHG. Bisects means cuts in half. So is this piece exactly the same as this piece? It has to be, because that angle on the top corresponds to that angle in the bottom. And because these two triangles are congruent, corresponding parts of congruent triangles are congruent. So those have to be the same. It was the same on this side. This angle is the same as this one. So that means HF does bisect that big angle in half. Diagonal FH is perpendicular to FE. Here's FE. I'm going to highlight it. Does it look like FH is perpendicular to that? No. Can't assume by looking, but there's nothing to guarantee that that's making a 90-degree angle. And lastly, FEH, I'll use 3 marks here, is congruent to FGH. Those two angles correspond to each other. They're in the same location. And because these two triangles are congruent, right, corresponding parts of congruent figures are congruent. All right, number 3. Reflect right triangle ABC across line BC. Across BC. Boom. Miss Austin's straight edges are all missing. Oh no! What am I going to use? I'm going to use a Post-it note paper. Living on the wild side. I should be using a pencil. Pretty good. So this is A prime, and I know that's 90. And now it says classify this new triangle, this whole big triangle, according to its side lengths, A, C, A prime. What kind of triangle is it? Well, let's see. I don't know anything about the angles. I mean, well, I do know that this angle is the same as this angle. And then I know that this side is the same as this side, and they wanted me to do side lengths. I don't know if this bottom side is congruent to this, but I do know two of the sides are equal. So if at least two sides are the same length, it's called an isosceles triangle. Because reflection preserves length, right? So when you reflect something, it's a rigid transformation. So AC is the same as A prime C. I know triangle ACA prime has two sides same length. So I know that I can call this an isosceles triangle. Number 4, triangle FAD, let's look at this, and DCE are translations of triangle ABC. So this triangle right here has been translated, right? Slid up here. This one slid over here. Select all the statements that must be true. B, A, and F are collinear. Well, a translation takes a point to another point, right, on the same line. Took BA to the line AF. Those have to be on the same line. Collinear means same line. Letter B, the measure of BCA is the same as the measure of CED. A translation is a rigid transformation. So that angle is guaranteed to be the same measure as that angle. And you could, if you weren't convinced, you could trace it. That's this angle, right? You slide it over there. See how it's the same? Line AD is parallel to BC. Line AD is parallel to BC. That's the bottom of those two triangles. And the definition of a translation is that it takes a line to a parallel line. These two are guaranteed to be parallel. The measure of CED, I already got that one marked, is the same as FAD. Let me put 2 here. FAD. I mean, you could trace it, but I don't, right? That's not the same as that one right there. The measure of angle DAC, that's this measure right here, is the same as BCA, which is this one right here. Now this one's a little bit harder to see, but do you see how I've highlighted these two parallel lines? I'm going to lengthen them. If these two yellow lines that I've highlighted are parallel, then this line coming through is called a transversal. And these two would be alternate interior. They are congruent. I can blow it up a little bit if you're just looking at that. It's this one is the same as this one because these two lines are parallel. Letter F, triangle ADC, that's this middle one, is a reflection of FAD. We could try it. I mean, doesn't look like it. So A, B, C, and E. All right, we're skipping 5. Moving on to 6. It says, identify a figure that is the result of a rigid transformation of quadrilateral ABCD. So lots of these you could pick any, right? The only one you can't pick is this one right here. That is not the same shape. So I'm going to pick this one right here. I'm going to reflect quad ABCD counterclockwise around B until C coincides with H. Watch one more time. Rotate around B counterclockwise until C coincides with H. Boom. So I'm going to say quadrilateral. Wait, which letter? I want to say it the right way. A goes to this guy, so it'd be FBHG. FBHG. I want to say those in the right order, right? Look, when I rotated it, A lines up with F, B lines up with B, C lines up with H. Okay, now how did I do that? I rotate quadrilateral ABCD on point B counterclockwise until, what did I say? C coincides with H. There's many more. That's just the one I chose. You could have done this one, this one, this one, with all different rigid transformations. Might have taken more than one. All right, guys, I hope that helped. I'll see you soon.